Hello everybody, welcome back to GameTitan. I'm going to try to do another stream here on CodinGame, and I'm going to try to do this a little bit differently because yesterday it was a little bit difficult to do the CodinGame competition at the same time as talking. So what I'm going to do instead is just go through and do one of these CodinGame I forgot what they're even called. CodinGame competitions. They're called Clash of Code. And after I'm done, I'll explain what I was thinking about. So here's one that's starting in 3 seconds. And I may have just missed it. So join a clash. And that filled up pretty quickly. So let's go ahead and start. Given nature n, print a number of primes with p less than n. Okay, that was a little bit less efficient than I'd hoped for, but we're looking for all of the prime numbers that are less than this number n. So because this is a timed competition, rather than thinking through the special case in the beginning where 2 is prime, I just started out assuming that 2 is prime and that we would check all of the other numbers between 3 and n. And there actually potentially is already a bug here, which is one of the interesting things about CodinGame. If you can just solve the test cases that they have, then you pass, but your code might not actually do what the problem asked. So one of the bugs here is if if n is 1, then this code is going to assume that 2 is prime and that 2 was less than 1, and it'll count that there's 1 prime less than 1, which is not correct. And another incorrect assumption here is that this loop is only going to go from 3 to 1 less than the way that Python works. It'll go to 1 less than the number, which that might actually be okay. And then we're going through this loop and testing every number. So in every number, we're going to assume it's prime at first, and then we're going to go through the numbers less than it, and for each of those, we're going to see if that other number, j, so the number I is the number we're testing, and we're going to go through and test to see that I is divisible by j, and if it is, then that means that j is not a prime number. So that's the definition of a prime number. So here is where we're going to go and test all of the numbers that are less than I. And as it turns out, all you need to do is test all of the prime numbers that are less than I. So that's what we're doing here, is testing the primes that we have so far. I had to add this in because when I didn't have it, the code was running too slowly on one of the test cases. And what this is doing is it's saying that the biggest number that could possibly still divide I is going to be the square root of I. That's the number when you multiply it by itself, is going to equal I. And so any number bigger than this, if you multiply it by something and it equals I, then that other thing is gonna, you have already tested it, so there's no reason to check again. You would have already determined that was a way to get I, and so you only need to check the smaller half of each multiplication, and that's what this does. So here's the test to check whether or not I is divisible by j. It's saying when you divide I divided by j and you take the remainder, if that remainder is 0, then I is divisible by j. So if that happens, you know that I is not prime. And if you go through all of the primes, all of this loop here for j and primes, and none of them are divisible, then you know that is prime still going to be, this is prime variable still going to be true, and you can add I as one of the primes that is smaller than n. Let's see what this person did. So this is Ruby, and this guy is is using a Ruby library that has a prime library in it. So I actually wonder if Python has a prime test in the standard library. That would have certainly made things faster. It looks like not, so Ruby was a good choice for this particular problem. Let's go ahead and try one more. Looks like this clash is still going on. Alright, luckily we picked one that started quickly. Middle of winter, winter blues go bad. You need a puppy. The roads run north, south, and east, west. So you need to calculate the distances by adding together the difference in x and the difference in y. You have a house and a list of pet store locations. So the house is the first line, number of pet stores, which we'll ignore, and then each of the pet stores. So these are all already parsed as integers here, and we need the distance. And the distance is going north and south. So we have the difference between hx and px, plus the difference between hy and py is going to be the distance. And we say that the best distance is some big number, and then we'll say if d is less than best d, then best d equals d, and we'll need to print out the one based index of which pet store is nearest to your house. So the best, and this is going to be best I is I plus 1, because I is starting at 0. Return this to the lowest index. Alright, so this is going to print best and best d. Hopefully this works. Best ID. Oops, this one was supposed to be, I didn't read the instructions. This one was supposed to be to reduce the size of the code as much as I could, which I'm definitely not going to do well because I didn't spend time doing that. Let's share my code. So here, the problem was saying that you have a grid of a town, and you have your location on the grid is represented by these variables, hx and hy. And then you have a bunch of pet stores that are being read into these variables one at a time, px and py, but there's a bunch of them. There's n of the pet stores. So you can only travel left and right or up and down. And if you think about it, no matter which way you travel through a grid, you can imagine there's a grid here on the screen. If the pet store is, let's say, 3 spaces over and 3 spaces down, no matter how you kind of travel stair step or going straight down and then straight to the right, or straight to the right and then straight down, no matter what you do, you're going to have to move 3 to the right eventually. 1, 2, 3, or 1, 2, 3, and you also have to move 3 down eventually. 1, 2, 3, and so that's the most efficient way to get from your house to that particular pet store. So here we're just saying take the difference in the x-coordinate, that's left and right, between your house and the pet store, and it doesn't matter if it's negative, meaning you're going to the left, or negative meaning you're going to the right here, or positive meaning you're going to the left, because that means your house is higher x than the pet store. Either way, you just want to know what that distance is. So this ABS function is the absolute value function, and will return, if you have a negative or number, it'll just return the positive version of that number. So you do that both for x, which is right and left, and y, which is up and down. And you keep track of the best distance that you've seen so far. And I just started that out as a very large number to make sure that it gets replaced, and the best index. And one of the things that the problem statement mentioned was that you are doing one index. So in Python and many programming languages, when you loop, your loop is often starting at 0. That's what range does. It goes from 0 to n-1. And so when we save which the best pet store was, we want to make sure to add 1 to it. And then we print it out in the format that was asked for. Let's try one more, and then I will sign off. Oh, let me actually just check the chat. Hi everyone joining the chat. I am a programmer. We're connected now. That's great, thanks for connecting. Someone posted a robot face on the chat in Twitch. And intro says, are we playing private clashes? I don't actually know if there's a way to do a private clash. Oh, there's 4 spectators on CodinGame, or on Twitch. Hello, welcome. Thanks for joining. How do I get back to clashes? Let me move this chat window over so I can see it. Alright. Is there such a thing as a private clash? I didn't actually see one. Oh, private clashes. Do you want to do a private clash? We can start one. Paste the. Joins that, I'll know that there's interest. Otherwise, I'll just go back into the public one. Oh, hello. Nice to see you. Alright, I guess I'll get started. Oops, sorry. Let me cancel that and start again since someone said link. This time I'll wait for a minute maybe. Oh, there's several people. Great. Let's get started. Hello. Payload into orbit, a rocket needs F equals P times C kilograms of fuel. So F equals P times C. It's messed up. For each kilogram of payload. To lift the additional mass of F kilograms. This is confusing. F2 equals F times C kilograms. F times C. So the first iteration is also and Not sure I'm understanding this question. And so fuel. I really don't understand this question. So energy for the mass of the rocket. To put a payload of P into orbit, a rocket needs F equals P times C. C being the cost of fuel for each kilogram of payload. So we're given the payload, and we're given C. This is just not 1000 times 0.5 is 1500. I just really don't understand this question. So there's the rocket plus the payload. Find the mass of the rocket. The mass of the rocket is supposed to be 1500. Since the mass of the rocket is 1500 and the payload is so 0.5 is the cost of kilograms per cost of fuel per number of kilograms of fuel per kilogram of lift. So 8.5 times some weight is equal to and the weight is supposed to be 1500 plus 1000, because 1000 is the payload and 1500 is the rocket, and then that's I unfortunately really don't understand the language in this question. The weight of the rocket is more and more precise. So we're given the mass of the payload and the cost for each kilogram to lift. we don't know the cost of the rocket. So we know that 1,000, 0.5, and 2 is supposed to lead to 250. 1,000, 0.5, and 1 is supposed to lead to 500. 1,000, 0.5, and 100 is supposed to lead to 7 times 10 to the minus 28. Sorry, this is supposed to be 1,500, and this is supposed to be 1,750, and this is supposed to be 2,000. Well, maybe someone else can explain this one to me afterwards. Yeah, I don't like this problem either. This is approaching 2,000. So half of 1,000 is 500. So this looks like it's I should use round. Are you talking about for the prime number problem? These examples are not written in the problem. I was just hitting play test case. Nine, 5, and 20 leads to 189. So this went up faster in the second closest. Oh yeah, that's true, but I was pretty sure that's not the issue here. Because it's expecting 1,500, but 1,000 times 0.5 is 500. So I'm pretty unclear. I'm pretty unclear what to do here. This description is very terrible. So unfortunately, with this program, we can cheat. Although it's very unsatisfying. This is not actually the answer. We could just, since the example code, well, there are some test cases that get run afterwards, so you can't actually do this. Yeah, I have no idea what this problem is saying, unfortunately. Oh, I see what you're saying. So this is 5. We're subtracting. I see. We're subtracting 500 and then subtracting 250, and then slowly it gets to 0. So you're saying fry and range, and we have P, which I'll just subtract from it. P times C, and then we're saying P minus equals F So we take 1,000. Plus. No. Plus equals. We need to. I don't understand why the English of the problem means this. But thanks for pointing out the pattern. So that one, I just looked at these examples and it took a while to dawn on me that this is adding adding half of 1,000 and then adding half of 500 and then adding half of 250 all the way up till here. Hello, nice to see you. Oops, let's do another of these. Should we do another private one? Let's start. I think there might be still some people. So hi, Coder Archer on the YouTube channel. This is a website called CodinGame, which has a bunch of problem-solving puzzles on it, and they have this timed competition where you can solve really short programming problems with whatever programming language that you want, and you can kind of compete against each other. Obviously there's 3 people in this private clash now. I don't know if anyone else is going to be joining. Well, let's just get started. X men, each man has X wives, each wife has X kids. You should print a total number of people. Is that it? Nope. X wives. Let's see. X times 4 is the number of wives plus X times 3 times X. No, that's not right either. X times 4. X men plus... Oh, sorry. X times X is the number of wives plus each wife's X times X kids. There we go. Oh, that was slow. That's very straightforward. Let's do that again. Compute. Whoops. Yeah, good job. Alright, so this problem was looking for Pythagorean triples, where A and B are part of the triple, and Pythagorean triple are three numbers where A squared, you could use different letters, x squared plus y squared equals z squared. And at first I thought that meant that these two would be the two smaller numbers. So a squared plus b squared would equal some c squared. So I took the square root of a squared plus b squared, and if that was, oh right, the other key point is they have to be integers. So if that was an integer, and I suspect there's a better way to do this. Is the float this integer? Is integer, so I could have done that. Like I said, if this is an integer, then print it out. But there are other cases where a or b was actually the biggest number. So this is testing the case where c squared plus b squared is equal to a squared. And this is testing the case where c squared plus a squared is equal to b squared. And then they had one other case, which I was not thinking about because even though it is a Pythagorean triple, it's not actually a triangle. Check my solution. This is much shorter. So here we have, if A is less than B, then we swap. That's right. Smart, that removes one of the cases. And then we say c equals, this is actually c squared equals a squared plus b squared. And then we square root it. Oh, that's a good way to square root quickly, is to take it to the 0.5 power. So if we square root it and then take the, oh, I see. So you take the floor of the square root and then square that again, and if it's back at c, oh, that makes sense. Then you print. What is this? Does this run? I've never seen this before. I have no idea how this works. Does this compile? Python 5.3 operator? Is this for real? It's all red. What operator is this? Right. I don't know how you got the code to submit 100%. That's pretty cool. Alright, let's do one more and then I think I will be done for today. If the output is there, it's a win even if an exception occurs. That is a good trick. Oops, I didn't paste this URL here. Ah, that is clever. Big brain time. Minus or a plus or exit, or 1 divided by 0. It's an abacus consisting of several vertical columns interrupted by a horizontal bar. Each column is 1 bead above and 4 below. Each column represents a digit of an integer. Hi, Tiny. Thanks for joining. We could probably turn this into a list comprehension. I'm just going to submit. That's clever. I like it. I can explain what I did. So, I found it easier to create the columns of the abacus as rows or as elements of this array. So I have this array L that I'm adding each digit of the number to. So I turned the number into a string so that I can just iterate through it with the syntax, character by character, but then you have to turn each one back into an integer, and then Y here is going to be the number of digit stones that are slid towards the bar, which is either 0 to 4 if the digit is 0 to 4, or if it's 5 then y is 0, and if it's 6 then y is 1, etc. to 9, and then y becomes 4. And then here, this first part is the top part of the digit. So it's this way if x is less than 5, otherwise you slide it towards the bar if x is greater than or equal to 5. And then here's the bar, and then we want y stones touching the bar, followed by a separator, plus 4 minus y stones after the separator. And I had off by 1 error here. Initially I said 5 by y. I'm just explaining what I was doing here with this code. And then there's this Python trick that lets you transpose an array. And what it does is it passes each of the elements of the array as separate arguments to zip. And so zip is taking the first element of each of the elements of L, followed by the second one of each of the things from L, and the third the third one from each of the elements of L. I got a comment saying my keyboard is loud, and yeah, something about my microphone setup. I need to figure it out, but I have a mechanical switch keyboard. So I went through each of those. So it's kind of the first character here, like either this one or this one from each of the elements, etc. And then those turn into arrays, so I turn them back into strings at the end. Oh, very nice, 96 characters. Oh, that is very tricky. Very, very tricky. Oh, nice with the print. That is cool. Alright, well, thank you everyone for joining. I'm going to sign off now, and I hope to see you next time.